thank you. Thank you for the invitation to Alex. And I'm actually glad this is remote. Otherwise, I couldn't come. It's just crazy how much to do is this year. And the last time I was in Bucharest, what I remember is a really nice coffee shop in the near of the Vox Days conference. So I found that per accident, and it was excellent. So this time my coffee is worse than, but this is like it is. So the idea, I think this is a great, topic for a keynote, because it is a little bit higher level. I tend to code a bit, but this is really hard to code. Otherwise, it will, take 1 month. We will code together a POC, and then after a month, we will get a bill and see, how it affected our, refactoring the bill. So it is not doable. So it's a higher level talk. I still really like Java. I don't know why. People ask me, I actually forgot. I wanted to show you my blog post recently. And there was like, what I've wrote is, because I got the same questions over and over again, it was like 1996, why I'm not using Python and Jython. Then later, why I'm not using Groovy. The big one was why I'm still doing Java and not Ruby on Rails. And now I would say Java is a little bit more popular than Ruby on Rails. Then Scala, why I'm not using Scala, Clojure, and recently I got lots of questions why I'm not using Kotlin. So actually, every 2 years I get the same question why I'm not using XYZ, and I like stick to Java. I like Java, and as you heard in the excellent session from Johan before, Java is going, had more and more interesting features. This was Java 17 now, and Java 18 is around. And I don't even know about all Java features. So if I would learn another programming language, then it would be even worse. Okay, marketing, right? So online courses or AXIO, how to call it, courses on demand, video on demand, you can download them. AX News, you get, marketing email from me when the next workshops are. AXFM is probably the most useful link here on this entire slide. And what it is are the podcasts with various luminaries from the industry. James Gosling was there, and Mark Fleury from Whitefly, and I don't know, 160 people already. So, and my blog is on Notepad, and AX Live are live workshops. So, okay. Oh, the second most useful link is AX TV. I'm answering all questions once a month here, just here, but not via emails. This is my time saver. This is why I still have, some leisure. Okay, thank you. Now let's start with Java. So why this session? So what I observed is that companies are moving to a cloud for a reason. So I would say since 3 years, public clouds became interesting for larger companies, but the expectations are completely wrong what actually a cloud is. And what happens then, some disappointment is going on. And what I would like to do is to show you the Java history, maybe, until the clouds, and see what's different and what we can do about it, or we can even proactively do something about that. So, and again, what I really like are questions. So I don't have nothing to code today. So the more questions and the more challenging questions, the better it is. Now, at the beginning of J2E, what I remember, presentation, business, integration, tiers. And there was huge discussion between tiers and layers. So the architects were happy if in the PowerPoints were, many tiers. The more tiers, the better it was. And there were crazy architectures, like, business tier were like EJB containers, load balanced. And then in the presentation tier, we had GSF load balanced, and they access the EJBs load balanced. If I ask them, why we have 2 sets of clusters, and the answer was, because of scalability. So look, but we have a single database, right? And so those are the craziness. So software quality, what we always did, and still sometimes I see this, I would say it stopped 2 years ago. All public methods has to be commented or documented, and what we have, documentation like this is a getter, this is a setter, this is a constructor, which is pointless. The next discussion is point number 3. So what I saw in projects is like, a list is new array list, and or in one project, what I remember, I got asked by developer why I'm not writing collection here. then I could more easily replace, the array list with something else. And there were this is like, trying to be perfect internally in Java. Decoupling, huge issues. So I would say, if I tell you DAOs are no more needed, it's not like right now everyone, shut down the Rocket platform and go home. Rather than you can say, okay, actually not that bad, right? Or data transfer object. I don't believe that you're still writing, data transfer object for every entity. So there's something else to do. But I would say 5 years ago, it was like almost like blasphemy, like saying, I'm not using DAOs. This was always fun to mention something like this, so everyone went crazy. What I noticed, people are now renaming DAOs to repository, but this is a different story. So code coverage is good, but what I see in production, just unit tests. Lots of unit tests, no system tests, no integration tests, and everyone is happy with 80% code coverage, but no one knows whether the system is working or not. Now, implementation independence was huge. I created actually the slides 1 hour before, so they can be typos. So if you see typos, tell me. Implementation independence, simple log4j. So I mean, all the logging frameworks were encapsulated at least once, if not twice, just to be independent from this particular logging framework. And of course, in cloud, you can write system out println statement, and everyone is happy. So this is why I'm telling you this. So we will come to cloud really soon. Vendor independence, we got JPA. To talk to Hibernate or Eclipse linked without changing the code. And what I already saw in projects like DAOs, they use DAOs to encapsulate JPA to be independent from JPA, and JPA encapsulates Eclipse link and Hibernate, which encapsulates JDBC driver because the database has to be encapsulated. So in the public cloud, what sometimes happen, the Azure people are talking to Cosmos DB directly without any encapsulation, and the AWS people are talking to a DynamoDB and without any encapsulation. So it seems like, complete different worlds. This is what I wanted to tell you. And this is not only, no one tells them what happens when DynamoDB goes away, or what happens when Google Spanner goes away, or what happens when Cosmos DB goes away, because if it goes away, there is no replacement for DynamoDB, and there is no replacement for Google Spanner. So we are already depending on the cloud. So playing with interfaces don't help us. Okay. Now, modular use, there was the next craziness I saw in projects. So the first occurrence, what I saw was Corba component model. And a little bit later was the EJB specification, which I'm actually really liked EJBs, but what I didn't use a lot was the remoting of EJBs. So I still use EJBs in some projects, but just, with the stateless, without the interfaces and Corba. And the next one, this is what I completely ignored, was service component architecture. I followed that. I got some questions why I'm not using this, and my answer was it was pointless. I never saw the point. And then we got ears on wars, I would say necessary evil. So, but what I tried to do is, if we had ears or wars, there was no internal jars. So one war meant to me, bytecode is directly in the war. And in the ear time, we had one EJB jar and one war, and not 50 modules. Now, at that time, I was happy with Java 5 and Java 6, and I got the questions why I'm not using OSGI services, because the services were lighter weight, and we could now create something like a mini cloud inside a runtime or a service. And so I completely ignored that because I already had OSGI indirectly. If you used Payara or Whitefly, or OpenLiberty, you have already the OSGI services under the hood. And if you really like, you could use them. But there was actually in my projects never the need to use OSGI directly. So more useful, shared nothing architecture. And this was the start of microservices. So this is actually this is the first idea what I actually applied in projects. So shared nothing architecture meant, for me, there are different meanings that we are creating one monolith, if you will. And this monolith is completely independent from other monoliths, so we could scale independently. But what we did back then was, I remember a critical projects, we did the opposite of modularization. I don't know how to call it. So we shipped in one war the entire bytecode of the entire application, but we were able to deactivate parts which were not needed. So the deployment pipeline was really simple. There was no unique snowflakes. It was just one how to call it, packaging unit, and it's the project was success because it was simple. And we of course architects ask me, this is a monolith. So no, it's not a monolith. It's a shared nothing architecture, and shared nothing architecture back then was very popular. So the hack is, of course, to sell your stuff and find the buzzword of the day and tell the people this is this, and everyone is happy. So and this is what I ignored. I think I never didn't deploy more than maybe 10 SOA services, and if I was in task forces helping to fix the problems, but I was completely against SOAP, and still I am. I mean, it disappeared, thankfully, but for me it was like pointless, which is not entirely true. As I already told you, Corba was around, and Corba was nicer than SOAP. It was much nicer than SOAP because Corba is very similar to gRPC. gRPC, yeah. The problem with Corba was you needed ports, you needed custom ports. So there was always problematic or challenges how to open ports in the firewall. And with XML RPC, which was the predecessor of SOAP, it was fairly easy. So I was happy actually about XML RPC, but SOAP was like was able to do everything and maybe even cooking, right? So there was like relaying on routing and stuff, crazy. And now microservices came, which were actually good because microservices, what microservice means is there is one process, at least if you search for definitions, you will what I always try to pick some known person like Martin Fowler and says, okay, this is one process which exposes HTTP and JSON to the outside world. And for me, microservices were like the ultimate modules. So what it means is, in my projects, I had an entire war. I think I did it even the last time at Vox Days in Bucharest, on stage probably. One war, one application server. I shipped everything, and everyone was happy. And if there are two modules, there were two application servers. Now we could use Quarkus or Micronaut or Helidon, something modern. And these runtimes will communicate with which is or OpenLiberty or Payara. Just there's too many runtimes so to call them all. And ultimate modules, why? Because they are completely independent. It's not like OSGI class loading hack, let's say. It is more like you don't even know what's inside. So you could you can implement one microservice in, let's say, Python, and the other one with Java. Not like you have to do this, but you could. So and this means the isolation was paramount, was really great. And these were microservices. The problem with microservices is what I saw in projects. Developers thought and are still thinking that they need hundreds of microservices. And what happens then is, of course, if you have 3 developers and 100 microservices, and in one point of time no one knows what's going on, and this is the beginning of the end. But you could sell an application with 100 microservices and tell, okay, the 100 microservices is like there's a single purpose microservices, and this is a great idea to do such a thing. And you could argue this way, but it is really hard to review, and this is really hard to develop because you will have to keep in mind 100 microservices. Of course, if you have 100 teams and 100 microservices, this is perfect. So then this is the perfect case for microservices. And by the way, what I try to do to estimate the quality of a project in a code review, I say, okay, I ask, I try to look up how the microservices are versioned, and if all microservices ship with the same version, this is almost, suspicious, or no, it's not almost suspicious. It is suspicious, and I will ask why you are doing this. Okay, on-premise means before clouds. And even if you are running OpenShift or whatever on-premise, on-premise is not, on Azure, Oracle Cloud, or AWS. So I would say, what's different? I would say what you have a few data centers. It's not like most companies don't have data centers around the globe. Usually we have one data center, and in this data center we have 2 machines. This is the common case. If not, now if you are working for Netflix, it's a completely different story. I forgot to introduce myself. I spend my time mostly in boring enterprise projects, and I'm usually not working for Google, Twitter, Facebook, what else, TikTok, or whatever. So for me, it's like database, still a kind of CRUD or communication between different microservices. So usually one data center, and then flat fee. It can be for projects. So and there are actually two categories. I see some projects which don't have to pay anything, so they have to wait for the infrastructure and they get it, and this is basically it. And the others are paying monthly or yearly a fee, and this can be really there can occur high costs or low costs. But what I didn't saw so far in enterprise is like pay per invocation model, or where you have a pay per use model. So then you say, okay, if you use more CPU, you will pay more, otherwise less. So this is what I didn't found in the wild so far. Hey, Alex, what's going on with the chat? Is there someone around in my talk, or is everything broke and you are the only person listening to me now?
Now you have actually 118 people listening to you, but they are speechless.
Ah, very good. So do you have a question at least? You are in the church. This is very good. In the no questions so far?
And I'm running things here, trying to wrap up.
Oh, you are not listening to my session. This is what I will note down. You won't get certificate of successful attendance. Very good.
I'm listening to my wife here.
Ah, very good. So listen to wife. Sorry for the interruption. Go ahead and yeah.
So you're good. You have 120 people.
120 people. Very good. So two people more because they saw your wife. This was the reason. Now, half automated deployments. So I would say what I also don't see in enterprise is like API. This is even if you have Kubernetes, they are creating Helm charts and shipping everything. It's not like they have something like the AWS as command line interface or Azure API. It is not as automated as in the public cloud. And the biggest difference is network bandwidth, power, ingress and egress are free. So projects usually, they can send terabytes over the network and no one cares. This was at least what I see in huge enterprises. If you are in different project, I would really interested if someone in the audience has to pay on premise for bandwidth on network. Backups are free. This is usually so, and hard drives are free, and multi-core compute is common. So what I would say in on-premise, we get usually 2 cores, 3 if you are on Kubernetes. So you can of course restrict yourself, or on Docker, but usually we could use on the machine 2 cores or more. This is what I see. Okay, now in the clouds, that's the difference. And because we are speaking about the costs, I just would like to show you the history of AWS. Why AWS? Because AWS was the first cloud, and the costs are also related to this. So AWS started in 2006 with S3, simple storage service. Now you will call it a serverless storage service, but back then was simple, and SQS was simple queue service. Actually, both are really serverless, and EC2. So what it means is, this is no kidding, if you have to store something, S3 and Glacier, if you have S3 and Glacier, this is the cheapest storage you can get on the cloud. The problem is it is a not blob storage. This is the name of Microsoft Azure. It is object storage. This is what I wanted to say. S3 is the object storage. And it's a little bit different than the block storage, which was introduced 2 years later. So this is the cheapest possible solution. SQS is a queue system, which is the cheapest system, I think. So it's cheaper than Kinesis. And EC2 is probably, if you even buy the compute in advance, the cheapest possible compute possibility on AWS. So whatever you will do is going to be expensive than the 2006 technology. So Elastic IP addresses, AZs, are multiple data centers per region. EBS is like a file system, and CloudFront is caching, was introduced in 2008. And EBS is more expensive than S3, of course, and significantly more expensive than S3. So what it means is, in the cloud, if you would like, to save money, the best way would be to work with byte arrays in Java and or not even byte array. Yeah, I mean store blobs of data as objects in S3, and don't use file system, for instance. Now, then we got VPC in 2009, and the VPC is actually one of the reasons why boring enterprises are going in the cloud because VPC is virtual private cloud, and this is actually a network. And what you can do, you can have your private area, which is not visible from the internet. This was not possible before 2009. So you got autoscaling, CloudWatch. And what is autoscaling is something which manages the EC2, and autoscaling starts and stops EC2, so it scales in and scales out, and scales out, yeah. And yeah, of course, it costs money. And EC2 without autoscaling is cheaper than EC2 with autoscaling. CloudWatch is log management system. Logging can be expensive, and therefore, on premise, I saw a project who logged like crazy, and no one cared, except they had some commercial, logging management software. But in the cloud, if you log too much CloudWatch, you will see it on the bill. So just, logging, I was in the method, and this is my parameter, and now I'm going out of the method, and this is the next method. Doesn't make any sense, and it will cost you too much money. So RDS is a Postgres database, which is significantly more expensive than S3 and EC2. And EC2 Spot is an interesting one because EC2 Spot makes EC2 80% less expensive, but you have to do something about that. So what it means, the deal is you can at most reserve 6 hours. So you can run for 6 hours, and what happens then if someone outbids you, you will have, you get killed in the matter in a few minutes, and then you can find another spot to run, but you can run cheaply. So you maybe will have, to re-architect your solution to save costs. So this is the first, thing you can happen. If you would like to run on EC2 Spots, you should be aware that you get, I think, 5 minutes of time to start another, home or EC2 machine. SNS are a simple notification services like the topics in JMS, and this is like the queues in JMS. CloudFormation is automation. So whatever we did in the data center before, have automated, right? So we created something and copied it to the operations, and they deploy that for us. CloudFormation is different. You can automate the entire thing with Java code, actually. So if you go to my YouTube channel, there's recently I recorded some screencast CDK, Cloud Development Kit. Why I did it? Because Java is actually great for that, and there are not lots of examples. I thought, okay, I can show that actually Java really rocks. So CloudFormation, Route 53 is also interesting. Such a thing like Route 53 is a DNS service, is available on premises, but what Route 53 does, it also introduces health checks, for instance, which were usually not available on premises. So you can do something about that. Of course, Route 53 adds additional costs. DynamoDB is interesting because the database, the most interesting feature of DynamoDB, the database is already there, and you don't have, you can just create a table without any installation. So at any time, this is DynamoDB. This is why it is interesting, for not so sophisticated application. I know there are a lot of huge fans of DynamoDB, and DynamoDB looks like Cassandra, very similar. And but this is for us Java developers more or less like hashmap of hashmaps. And but you don't have to do anything, and you're paying per invocation. So Glacier is like S3 but cheaper and with higher latency. This is the trade-off. And then Aurora comes. What is Aurora and Postgres Aurora? This is like serverless Postgres. And now two things: KMS. Why I'm mentioning a KMS, key management system service? This key management system service is quite interesting because you can store keys for encryption, which was not available on premise in this quality, I would say. What's interesting is one key costs I think 50 cents per month. So what I already saw, interesting approaches where they store in the key the entire JSON with several keys to save money. So this was some examples, right? ECS is Elastic Container Service, and ECS Fargate, which comes later, is the serverless solution to run containers. So what's the difference between ECS and ECS Fargate? ECS you have to to pick EC2 machine, and then you get ECS, and Fargate you say I need one CPU. Needless to say that ECS is more expensive than EC2. So ECS with Fargate I would say is 20-30% more expensive than EC2. And what it means is project may actually attempt to install Docker directly on EC2, but then of course you will have to manage the EC2 instances by your team. So this is always the trade-off. Will I spend monthly fee or maintain the entire infrastructure by myself? And Lambda is like Java method. Actually, Java works great as Lambdas. And I also recorded a screencast yesterday and compared the performance of Lambda with JavaScript, and just telling you, very similar performance. So you don't have to go to scripting languages. And by the way, this was Hello World Lambda. If I would put more code there, then the Java Lambda would be more performant than Python or JavaScript Lambda. What it means is with Java, we can actually save money. And save money means if you have lots of invocations, 10%, 20% per month. Then Aurora PostgreSQL and AWS Private Link. And the private link is actually huge. This is why I told you a few years ago something happened. And this is, for instance, what this is, that enterprises got your direct connection outside of the internet, direct connection to the cloud. So this is like extension of the data center, which is more secure to go through the cloud. Okay, so this was what I'm telling you with that is that this is like the releases and the services are built upon each other. So for instance, this Postgres uses EBS, and EBS can be archived to S3. So no, this is the base layer, and the cheapest one, and whatever you use on top of that is going a little bit more expensive. So now cloud-driven architecture, actually cost-driven architecture, or both. So now, what's the difference? So actually, I have to change it. The idea was cost-driven architecture, but cloud-driven architecture is also okay. CDA. So what's the difference? Bandwidth costs you money, and not only bandwidth. If you're connecting through the internet to the cloud, also the communication in the data center between machines costs money. Then egress costs usually money. Ingress not always, but usually. Then NATs, networked address translations, they are managed and instanced. The managed NATs are actually really expensive. So if you say, okay, I have I can tell you here, this architecture, presentation, business integration in 3 subnets with load balancers in between and NATs, and you have lots of traffic, this will be extremely expensive, or really expensive. There's nothing extreme, right? So, so the first thing will happen is management will come to you and say, why we pay that much cost for bandwidth? It's like, yeah, because we have 3 subnets with three nets, and it's like, okay, why? And what happens then? This will collapse, the layers usually to save costs. So internet gateways, endpoints cost money. IP addresses do cost money. So if you allocate elastic IP addresses, every elastic IP address, if not used, costs money. And storage costs money, and storage is cheap. What you also have to pay for is the storage access. So if you're invoking let's say you have S3 an object, and you just call, like in Java hashmap, give me the object. So every get you have to pay for. So what I already saw patterns where people try to cache, not to invoke too much, the S3, because it can get expensive. So what's the problem? The problem is that in the monthly bill, you will see everything. So there's like, no, S3 costed this much, the API cost that much, and this is the bill gets your manager. And what I noticed, this was actually a few years ago, there was a startup, and we started with Whitefly back then. It was like 5 years ago. And they already had the Whitefly, and we improved it a little bit. And it was very reasonable to have 5 microservices. They run on premise. And for, let's say, unimportant reasons, they had to go to clouds. And the 5 services in cloud would mean every service would be load balanced. So there are 10 processes with load balancers and so forth. So every service would cost, and we need stages and so forth, right? So every service would cost at least, I would say, 50 to 100 euro per month with all the staging and all the infrastructure. The first question of the manager is, could we merge everything back to one monolith? It worked well for years, and we could save monthly 500 euros. And there would be 500 euros per client. So this was like a product. And so this was the first thing, hey, this is an interesting take. So what it means is actually what we tried for years, build modules and microservices. Every process in the cloud costs money. And if managers see this, we as developers, we will have to justify why we built such an expensive system. So we have to say, okay, we build this microservice because, if there is a good because, great. But if they're just because we were on Vox days and Alex told us to create always 500 microservices for Rocket, this is a bad idea. Alex, everything is fine. Okay, Alex, everything is fine. We'll have, to refactor the Rocket platform next time to be more reliable. So yeah.
Stefan is deploying it already.
Stefan shut it down. This is the thing. And now if you think about this, a big Java monolith is cheaper to run than two smaller monoliths. This is absolutely true. And now also into another observation is, if you have one monolith in Java, and it's a reasonable monolith, let's say there's well structured and so forth, it can be actually fairly maintainable. So there is no need to have 2, 3, 4 microservices. And also an observation, the history of TypeScript, let's say, right? This TypeScript was invented because it was really hard to create larger projects with JavaScript. And what Microsoft did, this is at least my observation, they created TypeScript, to create larger applications than Microsoft Office Web or whatever, Office 365 or what's the name, 360. And with Java, we always could do this. And no one, I think, what I see, the project become too large, not too small. So we can actually build larger projects with Java without any problems. The problems were the first slide. So we had here, where was it? Java docs, frameworks, configuration. Oh, I forgot to mention here, but this was, I wanted to save slides. Configuration factories, abstract factories, decorators, dynamic proxies, whatever that we could build, we build just for fun. And of course, the scripting guys are more reasonable. No one, I hope not, will create in JavaScript, 20 layers and translation layers. It's just they just go to database and they are done. So, but in case, let's say, we are going to behave reasonably, what happens then? We actually can build smaller, larger units, but they are probably better maintainable than smaller units created in scripting languages. And what we need to know, we have to use packages properly, and we have to use the Java classes properly. We don't need interfaces, all the patterns. Just focus on business. And of course, now it comes. When we create one Java monolith, Java is very good with JVM, Java Virtual Machine optimizations, and it will even run faster than comparable JavaScript, TypeScript, or Python solution for sure. If it runs faster, we will pay less. If we pay less, we will save money, and everyone is happy, hopefully. Or no, we say, okay, but with Go and Rust, we could even save more money. This is to be seen whether Go or Rust, the performance is significantly better than in Java. But at least Java would be better off than scripting languages. So now, also true. So what I also see frequently is like the single-purpose lambdas should be small and so forth. And what also watch the recent screencasts. Why I recorded so many screencasts regarding Lambda and AWS, because in project I got questions. Yeah, is Java really suitable for clouds? And I say, okay, of course. And I say, okay, this is very fast. And they didn't believe me how fast it is. So okay, then I record a screencast, and you can watch it. I mean, you can try by yourself. We don't have to talk here, right? So now a single Lambda with 2 gigs is more cost effective than 128 megabyte Lambdas. The question is how it is possible, and what is the obsession with Java memory? So at least in AWS, what you should know is, if you start a Lambda with 128 megs of RAM, you get only 1/10 of a CPU, because there's relation between the CPU and RAM. But if you give a Lambda roughly 1.7 gigabyte of RAM, you get 1 CPU. And Java with 1 CPU starts faster and behaves better than a Java app with 1/10 of CPU. So what it means is all the RAM craziness in Java actually doesn't matter. And a Lambda on a Corretto 11 JVM, which is a standard Java virtual machine, may run cheaper than GraalVM. This would on the next slide. Why? Because GraalVM starts faster, but it doesn't optimize as good as Corretto. So nice observation. What it means is, the simplest possible solution is sometimes the best one. Okay, Alex, is there any question? So what's wrong?
Since nothing is wrong, I have the proof actually. Here, I'm watching you.
Okay.
People,
So maybe everyone is offline and we are alone here, right? This could be.
No, 108 people. So 12 people.
108 just, people, but this is just the counter.
Yeah. So people doesn't disagree, and yeah, I think I didn't disagree either.
This is unusual. In projects, no one agrees with me. On conferences, no one disagrees. So it's like strange words, right?
Yeah, because somebody needs to take the money for the cloud, right?
Yeah.
If everybody was deploying like you, who will pay the bill for the clouds, right?
Yeah, they should give me the money, not the cloud, Just kidding. Serverless. And there was lots of discussion, no serverless, but there are still servers, which is pointless. What serverless just means is if you have no traffic, you shouldn't pay anything. So this is serverless. And whether they are using servers or not, I don't care. What I know, if there is a Lambda, there is a server. Actually, it runs in Docker containers, so there is a server for sure, but I don't care. So what I think will happen is all profiling, what we did before, profiling, the CPU and memory and make it faster, will not happen in this. Of course, if you have a production problem, you will still do this. But what is more interesting is at the end of the month, you get the bill and you will look at the bill and say, why is this, this net or this account so expensive? And you say, okay, why is this expensive? Because we have, multi-region deployment of our server. And or the server communicate 2 microservices and 2 regions, and they communicate with each other, and these are the bandwidth costs. Okay, couldn't we merge them? And this will go into the discussion, I'm pretty sure. So whether the microservice is written, with Payara, Wi-Fi, Quarkus, or GraalVM is less important, because such a bandwidth cost can be higher than the actually execution costs. So serverless means no traffic, no costs, which is really good, because if you're running, let's say, Kubernetes on AWS, you are paying for the control plane all the time, regardless whether something uses your Kubernetes or not. It's just, the management of Kubernetes costs something. In serverless, it's not the case. In serverless, if there's no traffic, you usually pay nothing or almost nothing. There are some exceptions, like I think Aurora Serverless or Fargate, you will pay something if the task is running, but for the Fargate without task, you won't pay anything. So business traceability. So if we have this, what will happen? At the end of the month, let's say AWS Lambda, you will see, 2 million invocations, and you see this Lambda cost me that much. And we know that every Lambda invocation is a business transaction. I think the first time in the history of Java, we can go to management and say, look, your transactions, every ticket to Vox Days Romania costs on the platform, €2. Is it worth, are the attendees worth the price, right? And this is the now management decision, whether it is or not. This is called business traceability. And I think this is a good thing, because it makes transparent now. Otherwise, if you run, Kubernetes or something like this all the time, the costs don't change. Maybe, Christmas a little bit higher and then a little bit lower, but you have to pay all the time for everything. And also the CPUs are idle. Alex, is something? Because you appeared now magically.
Yeah, I was thinking of a question. Maybe it's cheaper, or what do you think about this? Maybe it's cheaper to have people that don't know Java, and maybe they are scripting, patching something together in Python or in TypeScript. They throw it into a Lambda and it works, and it's cheaper to pay those people to do something than to hire somebody with experience to do good monolith that actually works.
Yeah. Alex. So, but wait a sec, this is wrong folder. I was actually not prepared to code, but just for you, Alex. So this should create an Lambda function. And this is Lambda. So if you skip that, this is a hash map. It's maybe too sophisticated. But if I say, hello, Alex, I'm done. So it means if you're writing Lambdas in Java, I would say you need exactly the same knowledge as in JavaScript or Python. You need a basic hello world Java knowledge. So this is what I'm telling. And Monolith, the same. So you watch probably already my talks, hopefully, from the Vox Days Bucharest. So my way of creating application was very simple. You had, something like Facade with injected class. So there was, I would say, just bare metal business logic. I don't think you need specific skills. What you will need skills is a little bit. You have to know how to deploy the stuff. And in this particular case, it's a CDK. So it looks like this. So you will have to know, the which runtime it is, but you will have, in the case of Node, you will have to say Node 14. What is the memory? You have to know that, for instance, is 128 megabyte of RAM. You get only 1/10 of the CPU, and this you have to know. I would say, and this is the harder thing. And why scripting? Someone asked me recently why Python and JavaScript are so popular and Java is less popular as Lambdas. And I think the reason is, if you go to AWS console, and you can create JavaScript or Python Lambda just by putting, copying the text to the text box and say deploy. And in Java, we would rather use Maven and build this. And this is this is harder than directly copying the code. But imagine a larger project where you're just copying text pieces to Amazon console, and after 1 month, I would say there is no developer on earth who knows what's going on. I'm pretty sure. Regardless, because it is already challenging now. What I skipped here, the versioning. What you can do is Lambdas. You can say I'm shipping the version 1, then 2, and you can have hot deployment of the Lambdas. But if you just use JavaScript or Python in the console, I would say, and just in the console, imagine in JavaScript you have to write smaller code, not like Java. In Java we could actually, my Lambdas in Java, they comprise multiple classes. Why not? I mean, who cares, right? I mean, if this is cheap and we understand that, no one should be against that. But in JavaScript it's harder. There are no classes in JavaScript, so you have to write more code in a file, or you have to use ESM modules. And then I would say Java is almost as simple as JavaScript with ESM modules. And so and at the end of the day, Java will run faster and it's going to be cheaper. But what I think is that people don't believe that Java is fast. This is interesting discussion. 20 years ago, I have already justified myself why I'm using Java and not C, because C is fast and Java was slow, right? So this was like the same discussion. But very good, Alex. I send you a T-shirt next time, or bring a T-shirt, or you get at least a sticker. Exactly.
Thank you.
You get a Dracula T-shirt. I know that the Romanian guys hate Dracula. This is I learned in Cluj.
Yeah.
They say, don't mention Dracula again. So, okay. Then we did Horinka and Palinka and stuff.
Yeah.
So, logical over physical modularization. This is what Alex said. Very true. So you have partition, what you have to do is to partition the application nicely internally. But physical modularization means, instead of deploying 1 Lambda, you deploy 2, is less important and is even more expensive. And what you can absolutely do, monolith with Lambdas. So actually, what runtimes like Micronaut or Quarkus, what you can do with them is you can ship them as Lambda, and now it comes, but they come with an adapter layer where the Lambda events get translated to JAX-RS calls. So for you, it will look like a traditional microprofile or Java EE application, but actually it's a Lambda invocation. So in such a case, you can build mid-range, I would say, Java EE applications that you run as Lambda. And remember, the first 1 million invocations are free, so you won't pay anything. So it's also possible. But it is not really, I would say, cloud native. And what I understand on the cloud native is not that the application is running in the cloud. I mean, Java EE always run in the cloud. I mean, there was no problems with that. What cloud native means to me, using cloud features. This is why you're going to cloud. I would like to use the features and not, run in an EC2 machine, because there is no improvement comparing to on-premise deployment. And this is actually also what will happen. I think we will spend significant amount of time to find unused code. You are paying a lot in the cloud because you forget about resources. And as I said to you before, every resource costs you money. So, and this is actually, if you use the console, AWS console, if you click in the console, it creates behind the scenes far more stuff than you can see. If you use infrastructure as code like CloudFormation, CDK, or Terraform, you will have explicitly say what you are creating, and there is, apply and destroy, or deploy and destroy in CDK. So you have the opportunity to delete what you created. And so it is not insignificant to write your architecture in that way that you are able to delete the resources. What you will also find that creating NATs and network address translation and NAT gateways, exactly, cost time. So you're creating one, it takes 2 minutes, 1 to 5 minutes. So you'll be also careful, that your deployment will, will happen in let's say half an hour. This reminds me on deployment times on WebSphere 10 years ago. So that you get the same story in the cloud right now. So what I think what will happen is that we will get, there will be small monolith, but they are going to be deployed separately. So actually Java shines here again, because what we can do with Maven, we can create with CDK a small module with Maven, push it to Nexus, and reuse it across projects. And I mean, so cloud module is not, your business code, rather your infrastructure. It means this is the VPC, this is the subnet, this is the cluster settings, and this can be written once, packaged nicely, put to Nexus and reuse it. So with Terraform, significantly harder. You will have to set up a registry, and with CloudFormation, CDK works out of the box. So I would say finding unused resources is really hard. So now in Java, the question is GraalVM or JVM. So my advice would be start with JVM first. Why? Because currently GraalVM is a little bit slower than JVM, and 10%, but it starts fast and it saves memory. If you're using Lambda, memory is not an issue because you need CPU. So I think if your application is CPU bound, JVM is cheaper. If your application is IO bound, GraalVM becomes cheaper. Alex, you are back.
Yeah, I have a question from somebody. So
Lambda, memory is not an issue because you need CPU. So
we have somebody that says we have a bunch of Python lambdas that are plugged into a step function. Will it be better to move those to Java and perhaps combine them into a single lambda? Yeah, I have a question from somebody. So
Lambda,
I will just
memory is not an issue because you need CPU.
Yeah,
I read this. Alex, we have endless loop.
Yeah, infinity.
We are in Matrix right now.
Yeah.
So you can copy to my chat. What they do, they have Python in step functions. On step functions is something like small workflow with like Amazon proprietary language, and they are executed once after another. And the question is, if you migrate into Java, it's going to be cheaper. This was my understanding. Can you just copy it over?
I'm doing
this would be great. And so the answer is, if your application runs for a month, go to AWS budgets and you will see how much it costs. If this is under $1 million, probably it costs nothing, so they do nothing. If this is under heavy usage, you will be able to save with Java money. How much? I think 20-30%. This is my estimation. And if you do it, send me a mail or tweet. I'm really curious, but this would be my estimate. Okay.
And another one, I just pasted it into the chat.
Tiberio, very good question. Is GraalVM slower before or after JIT? I mean, what GraalVM has is the hotspot. So, very good question. Is this GraalVM JVM is faster after optimization? Put it this way. This is the correct way. So, what happens with JVM? it watches, your execution and optimizes it frequently. And one point of time is going to be faster than GraalVM, but the Lambda functions are reused. It's not like each time, you have a warm start, and a warm start means the entire execution was frozen and then is reconstructed, and then you get, the old optimization back. It's not like you have, to optimize over and over again. So, and cold start in Java is not as bad, roughly 400 milliseconds. I actually, yesterday, go to my YouTube channel, and you can watch, I think it was roughly 400 milliseconds, stuff like this. And the subsequent calls in Java, empty function, are 1 to 2 milliseconds. It's crazy. So this is the Java performance. Very good question. But if you have this, where is it? Monolith with Java with Lambda, it means you have Quarkus with a REST endpoint. What you can do with GraalVM, you can minimize the cold start to improve user experience. So this is a completely different story. So this is a trade-off. You have better user experience because the first call is faster, but you have to pay 10% more. But Lambdas, I would say, this is not an issue. But I have to be careful. Some of my projects, we are running several thousand transactions per second all the time, and this will make a difference, right? But if your Lambda is called, once an hour, no one cares. So it really depends on the traffic. Very good. Alex, thank you for the great questions. So,
not mine. I just right-click, inspect, and copy.
Very good. Yeah. Warm and cold starts. And warm and cold starts in Java, warm starts are very fast. This is like, the subsequent. And by the way, this is the funny observation. If EJBs, stateless EJBs, they behave exactly the same as Lambdas. To give you an example, EJBs, you can have mean pool size. You can say, I would like to have 5 EJBs at start time. And if you do it, what happens then is, they are pre-initialized on the server start, and then there is no latency on the first call. And Lambda is called provision concurrency. So what Amazon can do, it can, preload 5 Lambdas, and they are waiting to be invoked. No cold starts. You have to pay money for it, but it's exactly the same behavior. Now, if you don't do the min pool size and max pool size, what will happen is if you have 5 concurrent calls on stateless EJBs, you get 5 instances working in parallel because it was not allowed or was not possible that 2 threads will access the same EJB at the same time. The same is true for Lambda. If you have one Lambda and it's already busy and you have subsequent calls, the AWS Lambda environment will start, additional instances. So, so the cool story is, if you are Java E programmer, now you are the best time to become, the perfect cloud native guru or whatever it's called, DevOps, SecOps, and another cop, right? So, very good. Now, Fargate, also interesting. So I would say in the cloud, Kubernetes becomes less relevant, except lift and shift. You already have Kubernetes on premise and you have no time for migration. So the best possible choice is to use Kubernetes on AWS Azure. On Azure's AKS, and on AWS is EKS. And the best Kubernetes on Google Cloud, of course, because they invented Kubernetes. But actually, the AWS Kubernetes became open source. It's called AKS Anywhere, and you can download it and run it completely for free on premise if you like. But the point is, why we are interested in Kubernetes at all? And the answer is because we need someone who stops and starts the containers and manages the networking. And this is what Kubernetes did on premise. In the cloud, I don't need Kubernetes. On Azure, I can use Azure Container Instances. On Amazon, I can use Fargate ECS. And it is far easier to manage than Kubernetes. It's cheaper than Kubernetes. And now the question, why I need Kubernetes? So what I see already is that Kubernetes in the cloud is only used for legacy applications because they already had, Kubernetes installments and they push it to the cloud. But if you consider, just take a look, for instance, security on Amazon of Kubernetes, you have to manage the security twice, once in Kubernetes and the second time in IAM. And you have to do something about that, which is not trivial. But if you use Lambda, Fargate on something cloud native, which was invented in the cloud, then you get, the entire security is better integrated and easier to maintain, for instance. So and Quarkus is actually great invention. So I'm still delighted about Quarkus, and Micronaut is very similar. And Helidon becomes also some goodness of Micronaut. But what Quarkus is, this was the genius observation. Deployment should happen at build time and at runtime, and what Quarkus does, it observes all the dependencies and optimizes and generates bytecode. So the startup time is faster, and memory consumption is minimal. So if you're building, let's say, the monolith on Lambdas, Quarkus is possibly the best possible choice because you can very easily migrate an old, or it's very easy. You can migrate an old Whitefly application to Quarkus if you like. Okay, this was the last slide. I'm on time, so I saved 3 minutes. And are there any questions? Otherwise, I'm done. If you like, see you at upcoming workshops. If not, ask me questions right now, or AXTV or Twitter. Alex, something to copy?
Yeah, I'm looking now. Not right now. We are mocking Stefan because he wants to deploy a new version of the platform again. Yeah. And I know they are using Lambdas behind the screen. The screen they are using on Google platform. One thing I wanted to mention: you said the Google Kubernetes is the best, but is the most pricey. In my experience, it's more expensive than other Kubernetes implemented, like AWS or Azure.
What I really think is that Kubernetes in the public cloud doesn't make any sense. This is my personal opinion, because all clouds have their own orchestrators, and they are cheaper and easier to use than Kubernetes. And if you think about this, why I should create the Helm charts and everything if I have a simple container, and if I go to ECS Fargate, the entire configuration, the task is maybe 10 lines of JSON. And I can show you this. Yeah, and if I will move this to Azure cloud, let's say, then I have to migrate 10 lines of JSON. And I saw perform code review. They had several hundred lines of Helm. I would say this is just crazy.
I had a problem in the past. I deployed something with Google, their Lambda implementation. I don't remember how it's called. And their startup time, if your Lambda it's not warm, their startup time was kind of seizable. So we moved to Kubernetes from their functions. But yeah, if you can work with the functions, why not?
Very good. But I would say the AWS Lambda is already 7 years old and highly optimized. So they do a lot. So maybe in Google, but they will figure it out and will as fast as AWS. Very good.
We kind of had to stick with Google, but yeah, we needed to move in the same cloud.
Mm-hmm. Nice. It was nice chat with you. It was fun. What's wrong with the attendees? Do they have any questions? No.
They say Adam rocks, and we all know it. And Stefan is saying thanks, and he's hoping to see you in person in the near future.